Now we're going to look at converting units and just look at the similarity between the dimensional change we were doing before. Now, dimensional change, we were actually changing the size of the object. Now we're just changing the way we measure. So in a way, it kind of feels like you're changing the size of the object because you're going from big units of measurement to small units. So it's like you're going from a big grid to a little grid. So if you made the grids the same size, it does look like it's blowing it up. But really, in reality, we're just changing the units. The size is remaining the same, but the effect is very similar, or the strategy is very similar to dimensional change. So for converting units, you can either set up the conversion as a proportion, like we initially did for dimensional change, or you can actually set it up to using a factor. And in fact, when you do math later, converting units, it's usually going to be as a factor. So how do we figure out what the factors are? Well, there are two factors, one for the area and one for the volume. The area factor is in square units. So you're going to be squaring the ratio of the new units over the old units. The volume factor is in cubic units. So you're going to be cubing the ratio of the new units over the old units. You can tell what the exponent will be by looking at the units used. So like, I don't even have to tell you if I'm doing area or volume. If I say square inches, you know I'm doing area. If I say cubic meters, you know I'm doing volume. So square and cube are two key words. So you can tell what the exponent will be by just looking at the units. And this is also very similar to the dimensional analysis that you did in chemistry. In this example, I'm going to convert 1,800 square inches to square feet. Square inches, that means it's area. And I don't even really have to know its area. I just need to know that I'm going to square things. So my area factor is, I'm going to square feet, so I'm putting the 1 foot on top. And I'm changing from inches, so I put 12 inches underneath. And the exponent is a 2. Now that 2 is on everything in there. So it's 1 squared, foot squared, 12 squared, and inches squared. So my area factor is yucky looking. It's 1 over 144. Then I just take that and I multiply that by my original area. And you can see here that the inches squared divided by inches squared becomes 1. So you end up with just feet squared as your units. So I end up with 12.5 feet squared. In this example, I'm going to convert 3 cubic meters to cubic centimeters. So again, well, cubic, that means that's volume. But even if I didn't know it was volume, I know I'm going to be cubing everything. So my volume factor is going to be 100 centimeters, because that's how many centimeters are in a meter, over 1 meter, and I'm going to cube everything. It's amazing how much bigger volume gets, or how much bigger the units get with volume. If you go 100 cubed, that's 1,000,000. So my volume factor is 1,000,000 centimeters cubed over 1 meter cubed. Did you know there were 1,000,000 centimeters cubed in 1 meter cubed? So multiplying my old volume by my factor, I get 3,000,000 cubic centimeters is the answer. So how is the effect of proportional dimensional change similar to converting units? Well, both are related to, if it's area, it's squared. If it's volume, it's cubed. And it's pretty much just a factor being multiplied.